I'd like to talk about Python today. So if we say Python, what we understand of it? So basically Python is a programming language which is, you can say, kind of powerful, fast, as well as it can run anywhere, considering it is compatible with the operating system on which it is running, because it is friendly and it is an open source for development as well. So if we want to learn more about Python, definitely this is the best place to look at, which is python.org, where you can see that it has got multiple applications of which has an application of Python. Like, you can use Python for web development, for database accesses, for development of desktop GUI applications, scientific and numeric applications which considers machine learnings and AIs, for network programming, for gaming development. So these are all the applications where Python can be used. So Python has a more versatile application and usage in the market. Why Python? The main thing which comes in mind first of all is Python is open source. So what does open source means? So open source is something where the base programming code of the software is open for the public to have a look at, to involve in further development, and it can be accessible to anyone, free of cost, without any restrictions. So that's basically the main advantage of an open source software. So Python, being an open source, interacts many, it brings in many developers interested to chip in and work on the further development and enhancement of the Python framework, where more projects are getting developed, right? So that's why, being an open source, Python is one of the best advantage of it. Okay. So what is, I mean, being talking about Python, I would like to also start with explaining a bit of interpreters and compilers. So, what is Python? Python is a programming language, as I said, and it is kind of an interpreted language. So now, what is interpretation? So consider like we are writing a program. Would be writing in plain English, so it's kind of a high level language, and the machines on which the program would be executed kinds of understands machine level code, like in the bits, like zeros and ones. So there should be some software which would be translating the high level language into the low level language which the machine would be able to understand. Now for that purpose we have got basically two softwares. One is the compilers and one is the interpreters. Compiler is a software which translates the code entirely. It reads the code uh, from the first line till the last line of the code. It compiles it, it translates it into the machine level code, and then it gets stored in some file, and then it gets executed. The advantage of a compiled version of programming languages, might be the compilation time would be higher, where the all the checkings are happening whether the syntax are correct and all the other as, aspects of the programming software is correct. And once everything goes fine, the compiled version of the code gets created, which makes the execution time bit faster. So such as C, C++ are a compiled version of programming languages. Coming to interpreters, so interpreter has an kind of it differs from the compiler, where each line of the code is, it gets read, it gets translated, and then it gets executed. So the compilation happens line by line, from the first line to the last of it. Each line gets translated one at a time. So that means the one can start in a bit early on the development of any work, where you can quickly prototype your work. So there's comes the interpreted language. So Python is an exam is a type of interpreted language. Python, we have COBOL, we have Perl. These are interpreted languages, programming languages. So talking about interpreters, I would like to show you how actually interpreter works. So I've created this small UI for you, like to explain kind of the flow of an interpreted code. So over here, the very first block, if you see, this is you can consider this is an simple programming line of code where there is a variable, there is an assignment operator, and it is getting assigned with an summation of two integers, which is 10 and 20 in this case. So this is x equals to 10 plus 20. So now when we are coming to Python, what happens exactly in a background is, like, first of all, this line of code is getting tokenized. So what the tokenization process is, when we talk about Python and we are executing the code, the very first step is tokenization, where each line of code is getting converted into few operations and identifiers. For example, here x is an identifier, so x has been tokenized as an identifier. The equal operator has been assigned as an operator. The 10 integer gets assigned as an integer. This is again an operator, the plus operator, and this is again an integer. So likewise, each word of the entire code gets converted into tokenization, and it gets converted. The output of this process is tokens. So we get lots of tokens which we would be using further ahead in the process. The next step, what happens is, there is a parser in the Python interpreter. The name of the parser is a lexer. So what is the main purpose of this interpreter is, you can consider, like, in any language we do use semantics. We have lexical semantics. For example, if I say a noun, a pronoun, so these are somewhere it is defined in the like in the English language, that okay, these are called nouns and these are called pronouns. So those definitions, in the example of Python, are being kept in the parser. So parser do understands what kind of which all tokens are to be considered as an identifier and which tokens are to be considered as an operators. So that's the job of the lexer parser. So what it does is, it creates an abstract syntax tree. It looks something like this. For this above line of code, this is how the parser would be creating a syntax tree. It is just like a tree structure, where each tokens are being assigned and are being designed as an tree-like structure, where you can see the targets. That the target is something where we are assigning the value. So this is the variable x which comes under the target. The value section has got two operands. One is the left operand and one is the right operand, and we have an operator in between. The operator is addition operator, and the left operand and the right operand, we have got values which are integers of 10 and 20. So this is how the parser would be designing an abstract syntax tree. So the next process is, once this syntax tree get created, the next thing is to get the bytecode compilation. So what does bytecode compilation means? So this Python code we would be storing in an file extension called py, which is an extension to Python. Okay, all the Python's files are getting stored as a py with a py extension. So for this py extension file, once the abstract tree is got created, then the interpreter converts the high level language. This is still until this point, this is still in high level. This is still in English, and I mean, where we have got x, we have got 10, we have got plus, and we have got 20, and our job of the interpreter is to convert it into zeros and ones. Okay, so until this point it is in high level language itself. So now the actual compilation, bytecode conversion, is happening, where the each tokens are now getting converted into bytes and are getting stored in .pyc format. Okay, so .pyc format is the bytecode version of compiled version of, you can understand this as a compiled version of Python, the same Python file. Okay, so what's the advantage of having this .pyc file is that this pyc file gets created for with the very first time when you would be executing the file, the actual py file, and it creates the compiled version of the same py file and it stores in a pyc. So next time onwards, if the source code doesn't change, so this pyc file would be immediately picked up and this compilation process would not be needed. This three steps, this two step would not be needed, and directly the interpreter would start from this pyc file. So now you can understand, like when an interpreter starts executing a python file, any py file, it first of all looks for a .pyc file. If it gets it, then it skips this two step and directly goes to the pyc file and picks it up for the further process. But if it doesn't find it, then it goes to the tokenization process, then creating abstract tree, further creating a .pyc file, and then it follows the rest of the process, the step 4. Okay, so until this point we have got the pyc file created, which is a compiled version of the python file, and it is, since it is a compiled version, so it is like efficient in getting executed. It would be quite faster for the machine to understand. It is portable because we can transfer this pyc file at any and keep it at any place and get the python. If the python interpreter is installed on any machine and we have got this pyc file, our code would get executed without any issue. Okay, so once this process gets completed, with the output of this process is .pyc file. Okay, now comes in picture the python virtual machine. So the python virtual machine gets installed when we install the python executable. Okay, so it is a kind of a virtual machine which keeps on running on a machine, and the very purpose, it has got 3 steps purpose. The very first step is instruction fetching. You can consider this as whenever it goes and looks for a .pyc file, it fetches the .pyc file. Then the next step is to decode the pyc file to understand what exactly the operations were to be involved in it. So there comes in the AST tree, the abstract syntax tree, which was created and while getting stored as a pyc file. So it looks at the parser tree and tries to understand what was the operations the line was supposed to perform. So in this case it was x equals to 10 plus 20. So it reads this and able to understand the operation it is supposed to perform. So once a decoding part is completed, it then executes the parts. It then executes the exact line which was supposed to be executed. The very first objective of our program was x equals to 10 plus 20. So the python virtual machine exactly does the execution of the very first line by reading the abstract syntax tree and understand what exactly it was supposed to perform. So this is basically how internally the interpreter works and executes each line of python code at a time. And once each lines got executed, fine, then once the first line gets executed, then only the second line would get executed. So by execution I mean we each of these steps gets the interpreter traverses through each of these 1 2 3 4 steps to execute one line of code. Okay, another thing would be python being an open source. I would like to also show you what does open source means. So since we have seen over here that okay, the python is an open source code, so basically the python source code is kept over here in GitHub. If you want to see it, it's in github.com/python. Over here if you see, this is the basically this is the interpreter which we are using, the CPython, the C version of Python. The program is written in C. So the main source code of Python, whatever application we would be developing, all the programs, all the functions and methods are created over here. It is kept in these places. So this is, since it is an open source, you can basically go over here and take a look at it. Take a look at the source codes. Okay. Yeah, that was all about this short demo. Thank you.